24, derivatives. Definition of derivative. I keep telling you guys, it is important. It will always be important. Right now, up until today, it's been our only means of finding derivative. After today, it won't be the only means of finding our derivative. Okay? But we're still going to keep that definition of derivative in hand, because what you'll see pop up more than anything in like multiple choice questions and stuff is they'll ask, okay, what's the limit of this big old thing? And that big old thing is definition of derivative. And so you just actually have to take the derivative. You don't actually have to work the big old limit. Okay, so that's what you're going to see here. Now, part A here is new notation. We've kind of already talked about the fact that delta x, h, you can use either one. Okay, I can't ever think of a situation where, you know, it really matters. You know, multiple choice, obviously you can do whatever you do. Something like open, you know, like the open-ended part, the free response, that's the word I'm looking for. I don't know that they'd ever specify. I don't know that you'd ever have to show definition of derivative on a free response, but you might. So, okay, so instead of using the derivative of f of x, that's what that's saying, is equal to the limit as delta x approaches 0 and all of this, today we're using, so first of all, f prime of x, you've already been taught prime notation, right? So that's just another way to say derivative, is the limit as h approaches 0 of f of x plus h minus f of x all over h. So this is your official introduction of h, even though you've already seen it. Now, so example 1, use the h notation for the definition of derivative to find g prime of x given that g of x is the square root of x. Okay? So, I got my pen I was using already. I'm going to start as g prime of x equals. I'm always going to start with limit. This time it's limit as h approaches 0. Okay. So, I don't know, do we need to do a side note? If g of x is square root of x, then, holy, just wrote the wrong thing there. What I was trying to write is, what is g of x plus h? To get us to think through that. Because I think that's half of the roadblock to doing these problems for you guys, isn't it? What is, you know, so if g of x is the square root of x, what's g of x plus h? Square root of x plus h. Every place I see an x in the original problem, now it's going to be replaced with an x plus h. So it's going to be square root of x plus h, right? Okay, so that's just kind of, you know, reminder there. So, the limit as h approaches 0 of, says f of x plus h. Ours is really g of x plus h. So we're going to say square root of x plus h minus f of x, which in this case is g of x, so the original function of square root of x, all over h. It is not. That would be... No. And this is what one of the reasons they're showing this one is because we do have to take a different technique here. Because right now, if you plug in 0 as is, this is how definition derivative always works, right? You plug in, or I don't know, should I say always? I probably shouldn't say always, but if I plug in 0 right now, I'm going to get 0 over 0, aren't I? Which is a problem because that doesn't work for us. So, the plan here, and it's kind of a special technique, is we're going to multiply this fraction by the conjugate of the numerator. Because we have that square root minus that square root that just is ugly, we can't really do anything with it. You know, like, no, I can't break up that square root of x plus h. No, I can't factor anything out. I'm just stuck. We're going to multiply by the conjugate. So the conjugate of a square root minus a square root is going to be a square root plus a square root. So we're going to multiply by square root of x plus h plus square root of x all over square root of x plus h plus square root of x. And that's our math we're doing. And that is a common technique you see when you get in that situation. Okay? Because all we're essentially doing is we're multiplying that fraction by 1. By multiplying by the same numerator, same denominator, we're multiplying by 1. So on top, how do we multiply? Technically, we have to FOIL, yes. So when we, well, first of all, let me write limit as h approaches 0. So when we FOIL, what's square root of x plus h times square root of x plus h? X plus h, good. Now, because these are conjugates, what's going to happen? Middle terms cancel. So square root of x plus h times square root of x is going to cancel with negative square root of x times square root of x plus h, right? So I'm not going to write anything down if you can handle that. Now I'm going to move on. So that was first, outside, inside, last. So now we're ready for last. Negative square root of x times positive square root of x. Minus x. All over h times that lovely business. Now, I'm not numerator, I usually want to multiply. You'll often learn that denominator, there's often an advantage to not multiplying it together. I won't say always, but often. So I will tend to leave it just as the factor. So I'm going to leave this as h times, in parentheses, square root of x plus h plus square root of x. Okay? Continuing along. Equals the limit as h approaches 0. What happens on top? X cancels, and we're left with h over h times the square root of x plus h plus square root of x. Thus the reason we did not multiply that denominator together. The h's would cancel anyways, but it's much easier to see and do now because we didn't multiply them together. So h's cancel. So it's the limit as h approaches 0 of what remains on top if all else 1. If all else cancels, we have 1 over square root of x plus h plus square root of x. Now what? Okay, now we're ready to officially take the limit, plug in 0 for h. So now I'm going to have, I'm not going to write limit anymore because I'm plugging in the 0. 1 over the square root of x plus the square root of x, if you will. 1 square root of x plus 1 square root of x is 2 square root of x. And I actually have it left as this answer. Huh? I do not rationalize. Sometimes I do, sometimes I don't. The book sometimes does, sometimes doesn't. Thank you. There's a pass, okay? Thank you. Now, I'm going to rewrite this real quick. Not saying you always have to do this. This has a future purpose. Okay? What is the square root of x with an exponent? Okay. So x to the 1, the square root of x is the same as x to the 1/2. Yes? If I take that x to the 1/2 out of the denominator, what does it become out of the denominator? A what? A negative, right? Because a negative exponent takes you across the fraction bar. And so this could also be written as keeping the 1/2 x to the negative 1/2. Again, don't stress about that for the moment. There's no stress there. Let me rephrase. I said that badly. Okay, just don't stress about that. Don't worry about it all right now. You'll understand why later, why I did that. Okay? Questions on H? Good to go? Okay. The first and foremost shortcut we learn for derivatives is what to do if it is a variable raised to a power that is a number. So thus, today we are learning the derivative of x to the n. Now, over the course of the year, you will learn lots of derivative rules, okay? And it just comes down to, we accumulate them slowly, and so you'll just want to memorize them as we go, okay? So lots and lots of derivative rules. This is the first, and this applies to a lot, right? Because we do a lot with powers. So the derivative of x to the n has a new formula. And what this is saying is if you want to take the derivative of x to the n, where n is some number, right? The shortcut, you can still use definition derivative, you feel so moved, or take that power of n, multiply it by it out front, so you move the power out front, and then you subtract 1 from the previous power. Okay? Now, you guys are all giving me a crazy look, like it doesn't really, I think my best suggestion is let's try it. Yeah. Okay? So, A, find the derivative of f of x equals x to the third. So first of all, my notation, I'm going to say f prime of x. Okay, so if we think of this as x to the n, right? That means my n value was 3. So, n times x to the n minus 1. So we're going to move the 3 out front. So I think about, we bring the 3 out front. 3, x to the, it was 3. Now we're going to say 3 minus 1. I know, long way. Which is 3x to the second. That's how you do definite derivative of a power. Okay? So take the exponent, multiply by it out front, and subtract 1 from the exponent. Huh? Yes. That's it. You're done. If we apply definition of derivative to this exact same problem, guess what? You get that. And here in a moment, we can maybe go back and look at a couple from previous, just so I can kind of show you. It does work. Okay? Okay. So our rule we're learning is if it's x to some power, how we deal with it. Okay, what about b? Right. So before you can really do the derivative, you have to have it as x to some power. Well, if it's 1 over x to the first, I can't do the derivative of that, so make it x to the negative first. Now apply your rule. So, should I give you a moment? Or are you guys already ahead of me there? Find dg prime of x. So put the negative 1 out front, right? Negative 1, x to the, all right, officially I'm only doing this for today's purposes. It was negative 1 and now subtract 1, right? Which is, I agree, negative 2. So this is negative x to the negative second. What would you write that as if you're not leaving a negative exponent, though?
Negative x.
No. Yeah. If you have a negative exponent, whatever has a negative exponent moves to the denominator. So I'm going to say the negative of 1 over x squared. is what I have written. And that negative could be anywhere technically, just a negative out front of the fraction somewhere, 1 over x squared. And this is equivalent, negative x and negative second, but we need to make sure we know how to put it in positive exponents because that's what's more normal, okay? Okay. C. Yeah, we didn't stick on the easy ones very long, did we? Got a 50-50 shot there, right? Well, okay, here's the deal. Think about the square root earlier, right? The square root of x was x to the 1/2, and that's because a square root has an index of 2. So whatever that index is, whatever type of root it is your denominator. Yes. So this is x to the 2/5. And I guess I'm just saying that's how I remember it. Like the square root of x, I know is x to the 1/2, so that's my connection. So h prime of x. What are you doing first? Okay, 2/5 out in front. Okay, so I wrote down 2/5 minus 1, but Ross has a good point. How do we subtract 1? That 1 is going to be 5/5, and 2/5 minus 5/5 is negative 3/5. And obviously, you know, I am fine with you guys doing that in your head. You don't have to write this 2/5 minus 1 part. After today, I probably won't. Okay? I would jump straight to here. Now, what if we don't leave this with a negative exponent? What is it that has a negative exponent? The x. Where does the x go then? To the denominator. So 2 stays on top. 5's on bottom, x to the 3/5. I would have said leave it like that. In my answer key, I actually put it back in radical form. And I did 2 over 5, and then x to the 3/5 is the 5th root of x to the 3rd. It just, honestly, it depends on the situation. Okay? I'm not, you know, in my mind, both of these are correct. Only thing I can think of is since the original problem started with a radical, that's why you put a radical in the answer. I don't know. I agree. We'll just enjoy it as is, right? So, and as I said, I'm okay, depending on the situation, I'm okay with this one too. Okay, I'm adding in a D real quick. For D, I'm going to say that g of x is the square root of x. What is the square root of x? X to the 1/2, right? So this is where it becomes hugely important to be able to easily transition between radicals and what we call rational exponents, so fraction exponents. You need to be able to easily go back and forth. So, what are you thinking about g prime of x? I wrote 1/2 minus 1, but yes, I agree with 2/2. Yes. And for the benefit of what we're doing here, I'm just going to stop here because why did we just do this? Does this match our definition of derivative from part A? Huh? Oh, whoa, what did I? Well, I guess I zoomed out. Ethan just pointed out, I just wrote -2 up here. Did I say it right? Or did I say?
I think you said it right.
I think you said it right, because I wrote it right.
Okay.
Yeah, I noticed it.
Yeah, that should say -1/2. That looks really funky now that I tried to fix that, but yeah, I don't know what I was doing there. Okay. So, it matches, right? Does that give you some faith that definition of derivative and the shortcut match up?
If we meet on the topic.
You guys don't care, right? You're like, yeah, we'll just take it. But, I mean, they do. And so, like, on this review worksheet you're getting for the test on Tuesday, one of the problems says definition of derivative and must show work. You can still check your answer, though, using this method, can't you? Now, if you just put an answer on the test with no work, I'm not giving you the credit. I mean, I might give you 1 point for getting a correct derivative, but, if it's a 3, 4, 5 point problem, I don't know. I'm not giving you the rest of the points. Okay? So. Okay. There's no backside, right? We're done, right?
Can I see your book? I genuinely want to know. Well, I want to know what the problem was.
Okay, I'm going to get my book out too, so.